All right, continuing where we left off, although we will start with a quick review of everything because we've been moving at, I'd say, a pretty good pace. So we have this very simple main.dart file, which essentially its only child, or its home screen rather, is the game screen. You can see in the game screen, currently it's a stateful widget. We have sort of this temp function here just to experiment with what we've been building. Essentially right now this screen doesn't do anything other than has a button that says new game and then has the game board, which really is just game board. So no real UI work yet. We've been working on sort of like the models and our services. So to look at some of the files we've made a model for each of the things we care about: cards, decks, a draw, like pulling one or many cards, as well as the player themselves. Looking at a card model, for instance, we have things like an image, a suit, and a value, so on and so forth. We also built a service, and this service right here, the deck service, is what works with our API. Again, we are working with this deck of cards API, which is really, really interesting to work with because yeah, I think what I mentioned in the last one is, this API, I think was even originally made for kind of just learning purposes. We could very easily rebuild a lot of this logic client side, and it would not be a problem. But just kind of trying to show the common things that happen in any standard Flutter app that has to deal with an API. So that's why we're using it. So we have ways to essentially get a new deck, and we have ways to draw cards from that deck. So when we get a new deck, we call this, the API, and because we're inheriting our own API service, we have things like a base URL and some helpers to do an HTTP GET, so on and so forth. So we call it at this path based on that base URL, pass in, however many decks we actually want to work with, and we generate our deck model from JSON, which is a factory that takes that JSON and actually creates and returns a new deck model that we can work with. All right, one little thing I want to do, there's sort of in Dart, you're not really supposed to use, underscores for your variables. However, to me, it makes a lot of sense to use it so that it maps one-to-one with your API, so there's not some weird confusion. So I like to, I don't have a problem with this in my models, and I like to just kind of, for the file, have this guy here, so that I don't get those lovely warnings. Yeah, so something that's cool, just as a side note, in VS Code is it does give you these sort of warnings, errors, that kind of thing, and we could actually go through and fix these. For instance, it's telling me we don't need this file anymore. Cool. It's also saying avoid print calls, and I'm cool with it because we were just doing this to experiment. And then we have some constant constructors, which we can of course fix, and everything will be good there. So that's nice. It's nice to go in here and try and clean stuff up, keep things, refactored and nice. But I will ignore these ones because they will be gone when we actually make this. Okay, so what's next? I think we should do maybe some UI stuff, just to kind of get things looking a bit pretty. So I'm just going to close everything. In VS Code, you can do Command K and then hit W after, and it will just close all your tabs, which is nice. And let's make some components. Let's start with what should we start with? Let's start with maybe a playing card. Sure, let's create a playing card. So we're going to make that playing card.dart. So this is, essentially the, a card, a jack of spades or whatever it is. So we're going to create a stateless widget for this, and we will call it playing card. Now, I don't like to keep this open when I'm actually typing because it just starts throwing all these errors. Because of course there's errors. I just started typing. So I am going to go back to just my terminal window here so it doesn't annoy me. Okay, so in a playing card, we want to have a few things that we pass in. One of them is an actual card model, which we'll just call card. We also, let's pass it a size, just so we can kind of, if we ever wanted to make this, for iOS, make the cards smaller so they fit better, we can have that. Let's also have a Boolean called visible or not, because sometimes a card might be, face up or face down. We'll just use the word visible for that. And then that's good for now. And then we need to make sure that we are including these. So we definitely want to make sure that we are passing in a card. So we'll make that required, because without the actual card model representing the card, there's not much we can do. We'll also pass in, we won't require size because we'll set a default of 1. Size to me is going to be like 1 just means it's like 100% of whatever we set our default to. But you could, this is a double, so you could pass in 0.5 if you wanted a small card, or 2 if you wanted it twice as large, so on and so forth. Also, we need to do this dot visible, and by default, let's just make it false. So then we have a new playing card object. So let's go to our game board, which currently just has this text. So I'm no longer going to make it a constant. I am going to instead pass in the playing card that we just made. Now it is requiring a card. So for testing purposes, let's just make our own card by going card model. And we have to pass in an image. And again, I'm just going to kind of, this is just temporary. So let's just pass in, this stuff here. The suit, it's a king of hearts. So we should be able to just go suit.hearts. And the value is, what did they say the value is? King, all in caps. So then at least we have like, a card we can work with. So that means I can pass in card as card. And let's set, we'll keep size as 1, that's fine, and visible equals true, because we want to see the front of it. Okay, inside here, we do have a container. Now, I want to make sure that our container has a certain width and height. So what I'm going to do is actually, in my main lib, just make a file called constants.dart. And this is where we'll store kind of like certain constants. And I'm going to have a constant called card width. And it by default will be, and it's based I base this number off of this image. If we actually look at this, and I think if we inspect elements, we get, it'll tell us like kind of what it is, 226 by 314. So 226, and then const card height. And the reason I'm making these constants is because, I mean, they're not gonna, the defaults aren't gonna change, and it allows us to essentially reference them in different places that are gonna need to know it. For instance, showing the back of a card, front of a card. Now this is if we were to keep this exact size, this is pretty large, especially if it was like an iOS app. So I'm actually just right off the bat, just gonna do divide by 2. And because these are constants, they get compiled at runtime. There's no performance issue. Like you could do any mathematical equation here. I could just do this in my head or on a calculator, but let's just do it that way. So we have card width and card height. So what we want to do then in our playing card is make the width whatever the card height is, or the card width is, but let's multiply it by this size variable. That way we can change it. And same with height, card height. And of course, when you multiply by 1, which is the default, it's just going to be whatever that's set to. Let's give it a decoration, box decoration. And it's going to have a border radius, because we want to kind of give our cards a little bit of a corner. And we can do border radius dot circular and maybe 4.0. That sounds good. Then, so that's kind of like our container. And let's, in order to see this, let's just give it a color too. Color, oops. Colors dot red. Sure. So now if we go back here, oh, we didn't actually save this file yet. Card height is not defined. Oh, I didn't actually. Something that's kind of annoying. It's not annoying, but it makes sense. VS Code, even if you haven't saved a file, is already kind of like looking at your file changes. So it was, saying, yeah, you have access to this, but this file was never saved. So Flutter's like, I have no idea what that means. There we go. We have like a playing card just with that sort of red. You can see that little stuff there. Everything is good. Okay, so that handles, just the kind of the container for it. But we also want to actually, within that container, put that child. So First of all, we need to know whether it's visible or not. Because if it's visible, we obviously want to show, the face of the card. So if it's visible, and we can use a ternary expression here. So when it's visible, we're going to use that cache network image. That's that library we installed. We can actually just pass in card.image, and let's give it a width of card width times height, times size, and a height of card height times size. So this should always be the same, the same size. And then when it's not, I'm just going to do a container for now. We'll fix that in a bit. So now if we go back here, we should see, boom, there's our, our King of Hearts. Now we have this red here that in theory we don't actually need. So we'll just get rid of that. Okay, now I also want to have something that kind of represents, the back of a card. So we're actually going to make a new component for this, just so we can reuse it. So we'll call it card back dot dart stateless card back. And as usual, we need to import material. Boom, materials imported. Our card back is just going to take, at first, just a double of size. And this is so that we can pass that size parameter on. And similarly, this dot size, we're not going to make it required. We're just going to make the default a 1. And we're going to have a container, and it's going to essentially, and I'm just going to look at both these together because we kind of want the same, this same sort of thing. It's going to have a width and a height. Width with height. And let's just give it a color, colors.blue or something. And now we can use this card back whenever, and this can be a constant because, oh no, it can't be because we actually want to pass in that size, just so that if, there we go, size. And I don't think we need this trailing comma, just keep it a little more clean. So now here it's gonna look the same, but if we were in our game board where we pass visible, let's make visible false. And we see we have the back of there now. Now there's no border radius thing happening there. And I think that's just because we need to do, I think it's overflow or clip behavior. Overflow dot, oh no, it's now something changed. Clip dot anti-alias. And then we should see, so basically this is the thing that we have that lovely border radius happening, and anything within it, if it's, it'll get clipped out when you have that. Without that, you'll still see that, that the thing extruded outside of its parent. So we want to keep that clip behavior. Okay, so we got that. Now we could very easily, and we won't do this now, but we could, of course, in our card back, actually return like an image that looks like the back of a, the back of a playing card, bicycle card, whatever we want. But I'm totally, fine with this to represent the back of a card. I want to use maybe blue-gray though. There, yeah, it looks great. There's the back of our card. Awesome. So we have a playing card. Now let's go back to here and obviously make it true. And just to show like how this could change, if we made this the King of Spades, I'm just assuming that's going to be the convention. Spades, we should see that we get, that back. So there we go. We have a playing card. Okay, so that's a little bit of UI, which is cool, but it's not really dynamic yet. We're not pulling it from a server, so let's kind of start to get some of our game logic in place. So we're going to go into our providers. Now this is going to be kind of the meat and potatoes of our app. Game provider.dart. This is essentially what's going to kind of control the state of our game. Where like bot logic will happen. And this is the part I'm most excited about because my plan is to sort of build this in a way using abstraction. So we're essentially going to have a class that represents a game in general, like a basic card game. And this basic card game is literally a game where you can draw a card and you can discard a card, and that will be mostly it. And then the idea would be that we will actually have, something that would inherit that, such as in this example, it'll be Crazy Eights, but you could also, in theory, make euchre, you could make whatever, and it will rely on kind of the core stuff we're building now, but override things as necessary. So without further ado, let's get into this. Um, so we are going to be using a package called Provider to sort of deal with our state. And it's going to make it really easy so that when things change in our game provider, in essentially our game state, the UI will just update accordingly. So we don't have to think about it. I remember doing, code long time ago in like very basic JavaScript. And one of the annoying things is just because you change something in memory doesn't mean the UI is going to reflect, and dealing with all that's annoying. Obviously, like things like Angular and React has made those lives a lot better. And in Flutter, there's many different ways to do it, but I do like Provider. RiverPod's probably my go-to on real projects, but they have so many similar principles that I figured let's keep this as basic as possible. Okay, so our game provider. So this will eventually be what's called an abstract class, meaning you're not going to be able to actually um, work with it directly, but that will come at a future time. We're going to build this as if it's not abstract. Now, game provider, we're going to add a mix-in. So this is kind of like extending something, but it's more mix-ins are a little bit different than how we like extended our API provider. It's a way to kind of get the functionality of the change notifier without actually like directly relying on it. So we're using change notifier, and that's just built into material, nothing special there. But it is what something like a provider will be, wanting to work with. Okay, so in our game provider, we want a constructor. So anytime the game provider gets created, which in the cycle of your application should just be one time if you build it properly, but we want to initiate something called a service. So we're actually going to have something that's going to be late, meaning late is kind of a cool thing in null safety. From what I understand about it, uh, it's kind of like you're making a final variable, but it isn't initiated until after your constructor happens. So we essentially want to make our service equal to deck service. Now you'll notice I'm using an underscore, and that's because there's certain things in here that I don't want. I don't necessarily want anything that's inheriting it or like an outside class to directly work with. So this makes it sort of private. So we have our service, and that's all. That's all we have. We're also going to want a bunch of other stuff like things to manage, like what's in the deck right now, who the players are, what's been discarded, and so on and so forth. So um, let's do that. Um, so let's start with we're going to have a deck model. And it is going to be nullable because really until like when this boots up, we don't necessarily have a deck at first. So we need to call that API. So we're going to call this current deck. And you'll see I'm using underscore again, and then you're going to see this. This is a sort of like a philosophy that's used a lot, where you kind of have a public getter for these things. So we will also then put deck model, which can be null, get, and we'll call it current deck. And all it's going to do, and we can do this really easily, is just return current deck. So this means like we're kind of decorating the code that we're making to allow current deck to be accessed. But because it's a getter, you can't actually then like do anything with it. It's just, give it to me, and it's going to give you this sort of like private version of it. So this is kind of like, you think of it as like a proxy to get access to this publicly. But you can't really do anything, like you just get a reference of it. So we want something for that. We also want something to represent the players. So we're going to have a list of players, list of player models, because that's the model we made. And we'll call it players. And we are going to instantiate this right away as just an empty array, which is cool. Now, this warning is just saying, hey, this isn't being used because we haven't used it yet. So we can ignore that because we will be using it. And similarly, we're going to have a list of player models, and I'm just going to copy and paste it, called players. And it is also going to be a get. So, and what it's going to do is just return whatever players is set to. There we go. Boom. So we have players. What else do we have to track? So we have our deck. We have this. Many games have the idea of a discard pile. So let's also have a list of card model. And that's going to be equal to, or we're going to call it discards. And we'll instantiate it as empty because generally it's just, it's empty at first. And then let's make a list of a card model. Again, a get of discards. See this pattern? And it's just going to return discards. It's a little bit of extra typing to do this, but it just makes your code a lot more safe because you're kind of decorating what you want other files to work with and whatnot. And then let's make a, something that's useful in a lot of games is what's at the top of the discard pile. Like for instance, in Crazy Eights, it's important to know that there's a king of hearts. So you know I have to play a king or I have to play a heart. So we can actually do something where we return a card model, and it might be null, like if there's nothing in the discard. So, and we're just going to call this discard top. And what it's going to do is it's going to take the discards, and if it's empty, so if there is no discards, let's just return null, which allows a question mark, meaning like this is nullable. Otherwise, we're just going to return whatever's in the last spot on the discard. Dot last is just a nice helper. It's essentially the same as kind of going, discards dot length -1 to get the last index. But why write that when you can just go dot last? So there we go. That's just something we might want it at some point. Just try to make this as easy as possible. Something else that would be helpful to have is, and this will definitely come in handy when when we're inheriting and creating, games on top of our, base game. I like to just have something called like a map string dynamic, and we're just gonna call it game state. So this is something where like, the programmer, us in this case, or whoever's building a game on top of our game provider could just store things randomly and update them. So there's no, this is string dynamic. It could be like, hey, you could store like the value of Trump in here, which is something I don't necessarily want in my base game because like, not every game has the concept of Trump, but just something to sort of remember, things. So we will keep that. Okay, and then we need something to represent kind of like a turn, because in a turn you have, a current player, and oh, we want to know like we're on turn number 7. So we could just have a lot of, we could have a lot of variables like turn index, current turn player, blah, 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 blah. But this is a good case just to have another model. So we are going to make a new model. Now, this won't be a model that ever like we call an API for and actually, like work with in that way. It's going to be more, we're going to work with it just in, in this provider. So class turn. So something that is happening on a turn. I mean, in general, you obviously have players that are cross between turns. So I am going to make something a list of player model, and you'll notice this is final because when we instantiate this like turn object, like this turn object is going to be kind of like used throughout different parts of our parts of the app. We are going to require this on create. So let's just actually make that now. Required this dot players. Cool. Then we're going to have, these will not be final. The rest of these variables will not, because these will change. I don't want to like every time a new turn happens actually instantiate a new object. I just want to update the idea of like what's happening right now in this turn. So for instance, we're gonna have an index of, this will start at 0, but so on and so forth. It's also nice to just keep track of, the current player. Who's the current player right now? Draw count and action count. So, and eventually, like, there might be other things we want to keep track of, but this is be like on that turn, how many cards were drawn so that we can build rules like you're only allowed to draw 1 per turn, or how many actions were taken, playing a card or whatever. So let's put the rest of these in. We want to, when we create it, actually require the current player, this dot current player. The rest, let's just do this dot index. By default, it's 0 when you create it. This dot draw count equals 0, and this dot action count equals 0. So we got that. Now we're going to store the current player, but it might be nice to also store who's the opponent, who's the other player. But assuming this is a 2-player game, for the purpose of now, it will be. We can actually just create sort of like a getter for this, which will return a player model, and it'll be called other player. And all this is going to do is return whatever players we have, and it's going to find the first one where, and we'll just, instead of calling this element, let's call it P. And we will say where P doesn't equal current player. So it's going to return, the first one it finds. So if there was like 3 players, we would probably want to update our logic because it would just kind of almost randomly find, the first one that doesn't. In that case, we'd probably call other players and return, just make this a where clause where it actually returns multiple. But this is perfect for now. So we can, on our turn, be like turn.otherPlayer. Cool, it's going to give me the other player. And that's just going to be helpful for as we build stuff out. Another thing we're going to want to do is end a turn. So we can build that logic into our turn model as well. So I'm going to make a function. It's not going to return anything. It's void. We'll call it next turn. And it is a function. So what it will do is it's going to go index plus equals 1. So whatever our index is, it starts at 0, but when we go next turn, we want to increment it by 1. We're now on the second turn, meaning index of 1. We can also just, whenever the turn ends, we can essentially swap the players. So in this case, and we're going to keep this basic, assuming a 2-player game, but this could be updated in the future. We're going to just be like, okay, if the mod of the index of 2 equals 0, which is just a way of kind of saying, is it an even number? Is the index even? Then we can go players 0, otherwise players 1. So this is essentially saying, if our index is even, we're changing the player to be this one. If not, we're changing it to be the other person. Again, if this was multiple, if we had more than 2 players in this game, we'd have to update this logic. We also want to set the draw count back to 0 because the turns end and the action count equals 0. And obviously, if we ever wanted to track other things, we'd want to revisit this function and make sure that that we're resetting things back how they should be. Okay, so there's our turn model. Pretty simple. And the reason we made it really is because we also in here, and I'm going to do it actually up here because the turn is a pretty important thing. We're going to make a late object called turn, and we'll call it turn. We also need to import turn. And similarly, we're going to have a getter of turn, and it's just going to return turn. Return turn. Cool. Okay, so I think that's most of the, there'll be some other things we add, especially as we actually make the game a little more interesting, but this is a pretty good start. Okay, what are some things we want to do? We're going to, yeah, let's make, there's going to be quite a few functions we'll be making here, but let's at least make one so that we can start seeing this in UI, because I'm sure currently, I'm doing my best to explain, but seeing things visually is probably a lot easier. So I'm going to make a function, and I know that this function is, this is essentially going to create a new game, meaning I need to get a new deck. And luckily, we've done all the hard, heavy lifting for getting that from the server. So it will be a future because we are doing something asynchronous, but the actual function itself won't actually return anything. So we're going to call this new game. And I think when we create a new game, we should have to pass in a list of player models, right? And we'll call it players. So we're creating a new game. Now, when we create a new game, we need to get a deck. So we're going to go final deck equals, and we need to await, and we're going to use our service that we've already instantiated. Remember this service here to go new deck. Now you're seeing this is being underlined. That's weird. Why? Oh, because we need to actually, just putting future here isn't enough to say we're using async. We actually write async here. So then we get a deck. Then we're going to want to set that deck. So we could, I could basically just go, and in fact, I'll do it this way for now, and we might update this later, but we just want to set current deck equal to deck. Now, see, I am accessing a private property because I can. I'm within this class, and I want to in this case. Which is fine. But my UI that's going to be working with this service will never have access to this. It will be accessing, the non-underscore version, the protect the public one right there. So yeah, we get our deck, and then we set our deck essentially, and then we also want to set our players, and the players are going to be equal to whatever players we just passed in. So there we are. Then we're going to set, when we start a new game, we're going to make discards because we have that thing that's remembering, how many discards we have, which is this right here. We just want to make sure that it gets set back to nothing. Otherwise, there'll be some weird thing happening. And then we need to create our turn. So the turn is going to be equal to turn players, and we want to pass in players again. And the current player, we're just going to use players dot first. So whatever the first one is, which dot first is the exact same thing as doing 0. That just looks a little bit cleaner to me. All right, and then I'm going to make another function here just called setup board. because usually when a game starts, there's a little bit of setup that happens. We'll make it a future. Um, and we're going to call that here setup board. Now, currently, my setup board is going to do nothing because in our super most basic, version of the game, there's just going to be like a draw pile. There's not going to be like, oh, you get 10 cards, you get 9 cards, discard, whatever. But this is where when we're inheriting, we'll be able to do things. So setup board gets called. Very good. And then at the very end of this, we want to do something called, this is very important, notify listeners. So anytime, these things get changed in the code, the UI is not going to reflect it until you call notify listeners, because this essentially kind of is going to emit an event to be like, hey, some stuff changed, rebuild. So we need to make sure we have that. And we're going to have this in multiple places. Okay, so we have new game. Awesome. Now let's actually, start to implement this. So I'm going to go to my, first of all, my main.dart, because this is pretty important here. So normally your main function just goes, hey, I'm just going to run this app. But we want to run it and pass something a little bit more specific here. So I am going to essentially wrap this with what's called multi-provider. So I'm passing in something called multi-provider. Now this is part of the provider package, and this allows us to pass to have providers that can be listened to and whatnot. So the providers that I care about, I want to use a change notifier provider, not just a change notifier that will create an error that's annoying to debug. And in the constructor, in the build method for it, or the create method, we want to essentially pass in that game provider. And there we go. Then after that array, now I am using, technically we don't need multi-provider here. It could just be whatever the normal one is, but chances are we will want more providers. So I like to just use multi-provider. But we do need a child here, and child is actually that the app itself. Now this kind of change, this is like such a high level, change. We will definitely need to do like at least a green refresh here, at the very least for things to work. And we might get an error, but we didn't. That's great. Okay, so we have this, meaning we can access this provider anywhere throughout our app, and it is, what's cool about this. This is technically like a singleton. We're not going to have multiple instances of our game provider. So whether I'm accessing this in this screen or further down, it should be the same, the exact same instance of that game provider. Meaning you don't have 2 different games happening, and it gets confusing. Okay, so we got that. Then in our, let's do a couple things here. So I'm going to just close some stuff, and let's open up our game screen, which luckily already is a stateful widget. I'm going to get rid of our temp function. And we have this text button, right? So a couple things we can do. We want this new game button to obviously create a new game. So we are going to access, and I'm going to make this a late variable, and it's going to be final, of a game provider. And we're just going to call it game provider. So then we can access it in here easily. And if we had other methods, we could access it. But in our init state, we're going to go game provider equals provider dot of. And we need to say what kind of provider it is, and that's going to be game provider. We also have to import provider. You'll see, there we go, provider, except I didn't want it to do that. And we need to pass in the context, which we have access to anywhere in a stateful widget, not just in the build method. But we also want to then pass, in this case, listen false, because this instance of the game provider, or this like reference of the game provider, I don't want to be like constantly listening for changes, because I'm just actually accessing this because on pressed, I want to essentially call that function of new game. So we can make this asynchronous because we want to do some awaits in here. Async. And we should be able to just go await game provider dot, and you should say new game. Now it's expecting something called players. Rather than building all the UI to be like, create your players, we are just going to, create that for now. And we can always refactor later. And it's going to be a list of player models, right? And they need to have a name. So one will be called Tyler and is human. true. And then let's make another player model, and we'll call him bot. And is human false? But if you remember, in our player model, the default is false. So we could also just like, omit this, but I will keep it just so it's really clear. And then we pass in players. Okay, so this won't really do much yet, but if we did click new game, we will see, oh, a lovely error. So game provider has not been initialized. Okay, let's just do a hard refresh and see if we can figure out. Awesome. I mean, no errors showed. Let's see if, let's just see. We're opening up our network. I want to see if we click new game, do we actually make a network call? It looks like we do. So that's working. It is, essentially calling our game provider's new game, which the network call is happening because we're getting a new deck and all this stuff's being set up as expected. All right, so that's all we need to really do in our game screen for now. Obviously, if we had other UI functionality like, I don't know, restart game or whatever, we might, access things. So this is one way to access provider. And the only reason you want to really access provider in this way, at least in sort of the way I like to work, is when you're just trying to kind of like call a function. Like I'm not using this necessarily to get data. I'm just, using it to invoke a function that's here by using provider of game provider. Now for where it gets really fun is the other way to work with provider, or one of the other ways. So in our, where do we have here? We had a game board. And our game board, we really want to be essentially listening to the state of our provider and updating accordingly. So there'll be some magic that definitely happens in here. So what I'm going to do is kind of erase all this stuff because we don't need it anymore. And we are set instead. What we're going to actually do is return a stack. So a stack is like it's like a row and a column, except it's in kind of like Z space, so like coming at you, and it's going to have some children. And the reason I'm doing this in a stack is it's an easy way to sort of do alignment. So if we wanted something right in the middle, we can actually wrap our things in that. But let's just let's actually do that. Let's start with our align object in the stack. And we want to make its alignment alignment dot center, and its child will be whatever we're going to do now. And just to show what this is doing, let's grab this here. You'll see test 1, 2, 3. If we change this to top center, so you can see this is just kind of a nice, easy way if we wanted, because we're going to want to have some cards here, we're going to want some cards at the bottom, et cetera, et cetera. So there we go. We have that. Now within here, we are going to want this is where like our deck pile essentially is going to be. And let's figure that out real quick. In fact, actually, let's not even worry about that yet. Let's just keep test 1, 2, 3 because there's a lot we can do here. So you'll see I'm returning a stack, but really in the game board, I want to have something one level higher than that, which is going to be called, it's our consumer, essentially. It's the thing that's going to be consuming and listening for changes in our provider. So I'm going to wrap this in a consumer. Now there's no built-in helper for consumer, so I'll just use something like center and just change it to consumer. And we need to make sure we're importing this from provider. This is a provider package. Now, consumer actually doesn't use a child, but we need to pass a builder in. And the builder has 3 parameters. One is just the context, in case we want to work with the context downstream. Next is model, and next is child. Okay, so the one we really care about is model, because that's actually going to be like an instance of everything about our consumer. Now, something else we have to do here is actually tell it what kind of what are we actually consuming, and in this case, it's game provider. And you'll actually see now this just before, just to show, this is like, oh, it's just going to be an object. Like we don't know anything about it. It could be null, no idea what it is. But as soon as we actually tell it what it is, look, it's a game provider model, so we know what it is. And now that we have access to the model, we can do some sweet things. So I'm actually going to, so within, this is like the build function. So we actually want to, in here, return something like our stack and whatnot. So I'm actually going to grab this, paste it here, and there's some extra stuff we don't need, I think. I messed something up. Hang on, stack ends here. Let's just get rid of this stuff. return, and then semicolon. Perfect. So we're getting some warnings here, and that's because it's like, hey, this could just be a constant, but we're going to make changes. So let's just refresh. Nothing should be different, but let's do something here. First of all, right off the top, before we even do this stack, we should make sure that model dot current deck does not equal null, right? So just for let's get these things beside each other. So we have something called current deck, which is like a nullable field. And obviously, if there is no current deck, we probably don't want to try and show the deck because it'll just give us an error. So if it's not null, that's when we're going to return this stack. Otherwise, let's just return like a text that says, game, start game. Let's just make it say new game. Cool. So you'll see it saying new game. Also, our alignment got, because this isn't within the stack. That's right. So let's actually wrap this in a center. New game. And we could actually take this, a step further if we wanted and actually make this like a text button and do, what is it? What is the text button? I forget right now. Child text. Oh, I did text button, but isn't it? Is it flat button now? No, it is text button. And needs an on pressed. And we'll just, okay, cool. So now we actually get this like new game, meaning like, we could actually not even worry about having this thing here. And what's cool is we don't have to do that whole like, provider of because we have access to it here. We can actually just say model.newGame and then pass in players. And in fact, let's do it that way. I like this a bit better. So we will copy this final player model, need to import our player model, model.newGame, cool. And in theory, although I haven't tested this, new game, model.newGame. Oh, something didn't save. There you go. So this was kind of interesting, very basic in terms of provider, but kind of when you first figure out how this flow works, it's pretty sweet because essentially what happened, we called new game and we didn't do like, this isn't even a stateful widget, right? This is a stateless widget. We didn't even go like, hey, set state, after that to update the UI. But because we're listening, it knew to rebuild because something changed. And the reason it knows something changed is because we have this notify listeners. If I was to actually get rid of this, and probably might require just a green refresh here, and do new game, technically this code ran, and everything, there is like a turn in memory, and discards are blank. Everything is good, but there was no, we didn't notify it, so it doesn't go. So that's pretty cool. We're able to do that. So I'm actually then, just to kind of clean stuff up, because I don't think we need a new game button in both places, I'm actually going to just fully get rid of this action that's in our game screen, meaning we don't really need this anymore. We don't need this anymore. And in fact, like this could just become a stateless widget now, which I don't think you could easily refactor. So we won't really worry about it because we might want state at some point. But yeah, now we've just put this in here. Actually, sorry. We do need to keep this button because if we didn't, this would, once we're starting a game, if we wanted to create a new one, we wouldn't be able to. Like for instance now, because there's a game happening, we wouldn't be able to make a new one. I'm going to go make a new one, cool. Now that didn't work, but I think it's just because we had a pretty big change. Let's just see, new game, test 1, 2, 3. Now if I click it again, it in theory is working. As far as we know under the hood, it probably is, but there's no difference. It's just the code we have right now is like, okay, if there is no current, or if there is a current deck, show this. So let's, for instance, change this now to, instead of test, let's take model dot current deck dot remaining. Now we know, so this is complaining right now because it could be unconditionally accessed because receiver can be null. But we happen to know as the programmers that, hey, this will never be null because we're already doing that check here. So let's just go like this. And now you see test 52 because there's 52 cards in the deck. Perfect. Okay, so we're off to a bit of things here. Now we have no way to draw a card yet, so we can't make that number smaller, but we will get there very soon. Okay, so what I want to do is let's create a new component that represents kind of like our deck pile. So I'm going to go here, deck pile dot dart. And the deck pile will be fairly simple. We'll call it, sorry, this is a stateless widget, so we can do STL and just type this. It gives us the boilerplate deck pile. And we need to remember to import this stuff. So a deck pile itself, we will have an integer representing how many is remaining. We're going to have that just to kind of go with the idea of like because this is going to be represented by our card, we want to have that size property so that we can make things bigger. And lastly, we are going to have a Boolean representing whether or not you can draw from that pile. And let's just go and set required this dot remaining. So we always need to pass in remaining. This dot size, and it's just going to default to 1 like we're doing everywhere else. And this dot can draw, and by default, it'll be false. Okay, so within here, we essentially are going to use that card back property that we had, and we want to pass in that size. So we're just kind of forwarding the properties over. So now if we actually go to instead of doing our test thing here, let's just put our deck pile that we made. Because it's requiring, we want to have remaining, and this is where we would use model.current deck dot remaining, and again, exclamation mark there. So now we should see, instead of that, we actually have our back of our card. We have a deck pile, the card back. I do want, I am going to, because I realized playing card. Technically, I want on my, I want to grab this like exact same thing here that does the border radius, just so it has those corners. Now you're going to see this error. I was expecting this error. And this happens so you're allowed to put color on a container, but if you ever have decoration, you need to have the color within the decoration. And I think that's just so that like you can't put color in both places and then it gets confused. So now we just have that border radius. So that's all I was doing there. Just a nice UI update. Okay, so we're passing that. Now our deck pile is also going to, when we're doing a deck pile, I want to be able to show how many cards are in it. And we can essentially do that by passing something through here. So our card back currently doesn't support this, but we're going to have a final widget, and it's going to be allowed to be null, called child. Okay, and we're just going to go, we're not going to make this required because it's technically nullable, and we don't need it a default because it's nullable. And what I want to do here is we're going to give the container a child, and if it is, if child, what we can do is there's a couple ways to do this. So this is the most basic way. If child does not equal null, we want to pass child over, this guy here. Otherwise, we're just got like an empty container. Okay, now this is telling me this quick fix, which I am going to do. And this is just a much simpler way of doing that. This is essentially when you have the double question mark, it's like use this unless it's null, otherwise fall back to this. So that's a lot cleaner and obvious what's going on there. So the thing is now, the thing now is we could then pass a child over. So I could pass like some text, for instance, that has remaining in here. Now this is an error because it's an int. So we could either do .toString, which is kind of the ugly way of doing it, or we just literally put it in a string with a money sign and just go, oops, let's go remaining. So now we should see there that's 52, cool. Now because it's a widget, it doesn't necessarily have to be a single widget because a widget, it can be a widget with a widget inside it. So we can actually say, hey, we want this to be centered on the card. We also want, the style, text style, colors.white. So there we go. And then there's some things we can do. This is a constant that won't change. So there we go. It's telling us there's 52 in it right now. That's pretty cool, and we're getting somewhere now. So in our game board, which is where we've created this deck pile, we essentially want to make sure that that we can draw a card from it. So what I'm going to do is actually wrap the deck pile in a gesture detector. There's no shorthand, at least in my version of VS Code for that, so I'll just use something that I know will work, like center, and just change it to gesture detector. You could also just do like wrap with widget, but it doesn't really matter. And gesture detector allows an on tap event, as well as many other events. And this is where we do our logic to actually draw cards, which we have. Okay, so in this case, we're just going to await. So this is going to be async because we are calling an async function, and we're going to say model, so access to our game state, and we can do .draw cards, which maybe we haven't made that function yet. That's probably why. Let's go to our game provider, and let's see, what did we even make? Yeah, all we have is a new game. So we do need something to draw cards. That would be a good thing to do. So this will also be a future void of, and we'll call it draw cards. And when we're drawing a card, we need to know what player is doing that. So let's have the first field be a player model of player, and that's good. And then we can also optionally have an int of how many cards to draw, just so we don't have to call this function like multiple times. And I'm going to also just, yeah, no, I think that's all we need. Draw cards. So what we can do now is we can go final, and we can do a draw. And this is just using our service. Again, we need to make this async. Service dot, we should have something for this. See, we have the service for draw cards, using the functionality here. And what we want to do is when we draw cards, we need to use whatever the current deck is. And because current deck's nullable, we have to put this exclamation mark. And we know in our logic, we'll never be able to call this. And in fact, we could extra protect this just by going, if current deck equals null, let's just return so that nothing actually happens. So now we've like fully protected it. We'll never run into a null issue there. And then count, we're going to pass that count over, which by default will be 1. So we're going to do that. And something else that might be good to track, we have that turn object, right? So we can say, okay, a draw happened, and we can say turn.drawCount plus equals count. So that's just going to increment like, oh, this is how, that count, 1 card has been drawn this turn, or 2, or whatever. And then we want to take whatever our current deck is, and we want to just set its remaining equal to draw.remaining. So remember, our draw object itself, if we look at it, draw model, it has like this reference to remaining. It remembers how much is in it, and we will just set that to remaining, and all is good. Then, because we want the UI to reflect, we need to make sure after this function ends that we notify our listeners. Otherwise, none of this logic, this will be in memory, it'll be fine for the next time, but you'll skip out on like the rebuild until something else calls it. So now we have draw cards. And in this case, we have to pass a player in. So I'm going to actually use model.players0. Players, let's just do players at first. And this would be something we will, if there's multiple players, we need to make it a little more complicated. But in our game, the first player is like the human player. So we're good there. Okay. So I think this might just work. I'm going to refresh and do just this hard refresh. And one thing I love about building the Mac app, it's so fast that hitting this green button that cleans everything up is nice. So let's just click new game, and we see this. Now, in theory, if I click this, you'll see it's going down, and that's sweet. So I am drawing cards right now. We can't see it, but stuff is working. The next thing we're going to do is actually show what's in my hand and show, what's in the bot's hand, but most likely, we'll hide what's in their hand to make the game a little bit challenging. Yeah, hope you're enjoying this, and until next time.